Hi everyone. Good evening. It has been a long day, I know. Um, so I'm Tushar Gupta. I'm from Canonical, the company behind Ubuntu, and I work in the Launchpad team. I'm a software developer there. And today I'll be presenting on how you can build reliable dev environments with LXD Image Builder, and cloud-init. Um, so before we start with that, I would also like to set up context on why we want reliable dev environments and kind of the backstory of um, how I solved this problem. So um, I'll be using Launchpad, which is I'll be using Launchpad as a base example for this talk, and just to kind of get you up to speed with Launchpad, what it is. Here's some fun facts about it. So I mean, I kind of spoiled it already, but have you ever wondered where all the Ubuntu packages are? But um, I mean, when you do app update, you see a bunch of bindings getting installed. It's all released. So yes, it's Canonical's Launchpad. So all the bindings that you see when you do app update, those are built on a little machines. Um, um, th- on the Launchpad's build farm. So just to get you a bit more excited, here are some fun facts about Launchpad. Um, so Launchpad is old enough to drink beer. Uh, the first commit was there in 2004. And surprisingly, it also had commits from the CEO's keyboard. So I kind of stalked it to see like how the CEO's write code. Um, we can build for 8 different architectures. So everywhere you can install Ubuntu, you can essentially Launchpad can build bindings for those architectures. So at the moment we have RISC-V, the famous ones in the ARM, and also some architectures like ST90X, VPC64EL, etc. And I mean, I came to know a lot about Launchpad when I joined the team. Initially, I thought it was just code hosting, but it's not just that. There are a lot of other exciting features. For example, you can have personal package archives. There's a bug tracker, which is quite unique in the sense that it can track, um, you can basically log bugs across projects and link CVs to it. You also have some feature to specify translations for Ubuntu and a bunch of other features. So, I mean, when I joined the team, this got me excited. Um, and as any new open source contributor, what I generally like to do is try and set up the project locally so I can get a hang of how things work, fit around with it, play with the tech stack. So let's try and set up Launchpad locally. So first of all, you will install LXD. Why LXD? I'll come to this later. And I'm also curious, I mean, how many of you know about LXD already? Okay. Yeah, so you'll learn about it and later. It's a pretty cool tool. So first of all, you'll install LXD. It's used to like create system containers. Then you create an LXD profile, which is essentially you configurations that you specify for that instance to use. Then you'll launch an LXD container. Then you'll clone Launchpad. Then you'll have to bootstrap your SSH keys, which is essentially something we do to kind of connect a VS Code or any ID that you have with the VM that was just created. Then you'll run a Rocket Fuel setup script. So this script bootstraps the whole Launchpad project, and it does a lot of things. So while this happens, you can, based on your machine, you can go and watch one or two episodes of Friends. Essentially, what this script is doing is exploring a bunch of dependencies, trying to compile wheels for it. We don't use wheels from PyPy because we don't want like some kind of um, like like a supply chain attack where PyPy is compromised and we start using those wheels. So we essentially have source packages for all the dependencies and we compile wheels for it. And we use the same workflow in production and locally as well. So it takes a lot of time to kind of compile 200 plus dependencies. I have a potato machine, so it takes around 40 minutes there. And then at the very last, you run another script which bootstraps your database, seeds the sample data. And at the very end, you just cross your fingers and hope Launchpad starts. The reason you cross your fingers is because I have factored out all the complete processing to like this simple flowchart, but there are a lot of other nitty-gritty details. And if you get anything wrong, you'll have to start from the beginning. For a contributor who's new and who just wants to get started, this is a bit too much, and there should be something that we can do better. Yeah, I mean, I, I, there are very few people who got it right in the very first attempt, at least in our team. Um, So, which leads to the question, can we do better? I think this is the universal answer to this question, which is always, there also always scope for improvement. Um, so let's get into how or like what tools you can use to build dev environments locally. What we use at Launchpad to do it. First of all, we use LXD. So we wanted some kind of container where we can run Launchpad freely without worrying about it messing up with the host system or like conflicting dependencies that you have already installed on your local host and what is needed for Launchpad. So we use LXD for that. And when I was investigating, I mean, the first alternative that comes into your mind is basically Docker containers. Like, why not just use Docker containers? Um, so if you think about development environments, they're more like your local systems. And on the other hand, if you think about Docker containers, they are basically um, more tied to deploying service on correction. So for Docker containers, I mean the whole life cycle of the container is tied to the main process or like the whatever application that you have configured your container to run. So whenever that is restarted, your whole container restarts. However, in a dev environment, you will not likely want that. You likely want to have like multiple services running, and then like if you restart one, you don't want your LXT VM to also restart. Um, that's why I kind of went with using LXDVM. Apart from that, it also comes with systemd support. I mean, it comes with the systemd and the whole OS. So it allows you to also install snaps, perform some advanced operations, which if you try to do it on Docker, you'll run into weird issues. Um, that's why we went with LXDVMs, which are basically lightweight VMs that you can freely use. Um, so once we have the LXDVM in place, the next question that I had in mind was, how am I going to make custom images? So I was aware that the LXD team is building images for Ubuntu. They're publishing it. So there must be some tooling that they're using. Luckily, when I investigated, I found LXD Image Builder. It's an open source tool which allows you to paste the vanilla Ubuntu image and make customizations on top of it. Um, it's pretty simple. All you have to do is you need to go to the LXD Image Builder's GitHub repo. They have a YAML, which is like the default YAML that everyone should be using to, that is basically used to build Ubuntu images, and then you just make changes to it. You can find more about it in the LXD Image Builder's documentation, but it's pretty simple. All you have to do is change some values, which defines the metadata, which is basically like what would be the image name, which path, which architecture are you building it from, and then there are some actions and triggers that you can define to inject custom logic. So uh, this is these are basically all the attributes that we have in the LXT image builders. But the ones that I was interested in were packages and actions. Packages, as the name suggests, it's basically which packages do you want to be present in your custom image, and actions are essentially hooks. So every time there's a build process, there are different actions defined on for different phases of the whole build process where you can inject custom logic. So we used these two primarily to. So I mean these two attributes are majorly what we use to build the custom image. Um, you can see that we defined. This is how basically we defined all the packages that we need in our day-to-day Launchpad development. Um, and then you can see I defined the post files action. So a post file trigger. So each action has a trigger and then an action, which is essentially a custom logic that you want to inject. So I use a post files action, which runs at the very last of every of the whole image build process. And once that is done, I'm just running all the manual steps in this bash script. This essentially avoids I mean, users don't have to run the rocket fuel setup and all these steps manually, and they can just specify everything here. So once you do that, to build the image, it's pretty simple. You just use LXD Image Builder, specify the build LXD command, and then specify your YAML file. Once you do that, you will get an artifact which is going to be a tar file, and you can easily import it into your local LXD server. Now, um, let's think about what we have right now. So we took a vanilla Ubuntu image and then we customize it to install Launchpad on top of it. But dev environments are a bit different. If you think about it, they are also tied to the user who is trying to set up the machine locally, right? So there, so I mean, in our case, we wanted some customizations to also happen after the generic image is created, or like post build customizations. Um, for example, a common use case that we had was how do we inject users public key, which was like a common pattern that we use. So we inject users public key into the VM, and then you can connect via VS Code easily. Otherwise, everyone has to like consider those things manually as well. Um, so in order to do that, I researched a bit and came across these two tools that we can use. Um, so there's LXD Profiles and cloud-init. The both are declarative tools. There are chances that you've already heard of cloud-init because I mean it's widely used by a lot of public cloud providers to configure machines post. I mean to do first boot customizations, which is essentially when the VM boots for the very first time, you'll want to run some custom scripts. Cloud-init is widely used for that, and LXD profiles are basically as the name says, they're basically profiles for the instances that get created using that VM. So you can define networking, storage, limits. I mean, how many CPU, how much memory data instance should use when you when you start an instance using the customization. So um, once you do that, I mean, this is how we set our LXC profiles. So this LXC profile is basically generated by our script, which is used to glue everything together. Um, you can see there are like online 5 to 7. I'm basically mounting a folder from the host system into the VM so that any changes that I made in the VM is also reflected on the host system. The reason I do it is that for operations like git push or like any operation which requires authentication, I don't want my SSH keys or my authentication tokens to be copied into the VM so that I can perform those operations. Um, so basically, this allows a way for me to also access my workspace from the host system and also access it from the VM. But there's a catch. You'll also have to define the necessary user mappings. So um, because the files are just mounted, the permissions are essentially the same. So you have to tell LXD that please allow this user in the VM to make changes to the file which are owned by the user on the source system. So in this case, we defined a mapping for user ID and group IDs. Luckily, the user ID of the user on the host and the VMs was synced. That's why you see thousand everywhere. But I mean, there's a custom script which kind of figures out the correct user IDs and uses them. At the very end, I'm using a run command module of cloud-init to make some more customizations when the VM boots for the very first time, which is in Launchpad, it's apparently a bit difficult to figure out the right FT URLs. So having those for first-time users is pretty helpful. So it just adds those. It also does a bunch of things which is like not shown in this snippet. But run command module is essentially where you can specify a bunch of bash command to make first boot customizations. So um, now let's recap again. We have a generic we built a generic image that using the vanilla Ubuntu image. Then we had figured out a way in which we can make post boot customizations. Now comes the next part of it. How can you distribute that image? I mean, of course, you can like use the LXD Image Builder to build the image for the very first time locally and keep using it. But it will take 40 minutes for the whole build to complete before you can like use it to spin up more development instances. So we need to figure out a way in which we can easily distribute the images. Uh, Fortunately, LXD also comes with a image server installed by default in it. So when you do a snap install LXD, it also comes with the image server. So there are a bunch of ways in which you can distribute the image. The ones that I like is that either if you have like a self-hosted lab, install LXD on it and use it as a and just use it as an image server. You can configure your local LXD server to pull images from the remote LXD server, or even or there's even a simpler way in which you can configure your CI to build the image and just take that artifact and host it somewhere, put it in an S3 object storage or like um, anywhere where you can pull it from on the internet. Just a basic simple file server. You can download the image and then do LXC image import. So this is how you can distribute images with other or like within your team. And let's check out the new process now. So now you just install LXD, you run the rocket fuel quick start script. I mean, Launchpad has a lot of like space related terminologies. So Launchpad itself is like the Launchpad where projects launch. And then we had this old script which was about rocket fuel. So I went with that and added the notion of rocket fuel kickstart. So you run the script, you go grab a coffee. It will take maybe 5 to 10 minutes. And by the time you're back, you have a working Launchpad locally. So um, this is much friendly for a new contributor, and it also looks easier. So, I mean, for anyone who goes and checks out Launchpad, runs into some annoying bug and wants to just quickly fix it, this will be very much like friendly instead of the older process which goes into the every nitty gritty details. Um, so yeah, I hope this gets you excited about Launchpad. And if you want to contribute, you can go to bugs.launchpad.net/launchpad, where you can find a bunch of um, bugs reported by a user. You can just pick anyone or try solving it. You have a way where you can quickly and easily set up the Launchpad locally. And there's a bunch of useful things that I've added. You can go and check out all these tools that I just described. And thank you. We can do questions, or you can also grab me later. Do you have any templated images already hosted somewhere? Yes. So at the moment we have a CI which builds the image. So there's another. So the script that I showed, the rocket fuel quick start, it is pulling it from that file server and then downloading it. And that step also kind of does the part of like gluing everything together, where it asks your Launchpad username, it asks where to clone the Launchpad project so it can mount the right folders, etc. And doesn't have any form of layer caching like Docker has, because I can imagine for very large projects like building and downloading like images every time, it could be like a lot of bandwidth. So I mean, for the builds, I didn't actually check whether they are layer caching. I'm not sure. I'll have to take a look whether LXD has it. Mostly because I mean, I have a weekly the frequency is set to like a week, so the builds happen every week. It takes 40 minutes, so I never actually investigated into um whether there's layer caching. But one thing that I think is there is you can also like warm up LXD to load that image so that your instances start even faster. The default Ubuntu images, they start up pretty fast because they're already loaded. Yeah, this is something you can explore. I've never actually checked it. Thank you. As I understand it, LXD system containers are like full VA. We don't have to contribute VA freaking job. So cool. Thank you, everyone.